Hey guys, I'm back. So this is my newest completed project. It is a audio spectrum analyzer. The spectrum will appear on this screen, and as you can see from the cable that just fell down, you just plug it in with standard 3.5mm headphone jack. There's a jack right there. It has a standard a DC input jack just to power the thing, and a screen from AZ Displays. I think it's available on BG Micro for about $10. I'll link it in the description and on my website in the projects page. So if you go to this project, if you go to the project page, maybe this project will be up on there. If not, wait for it to go up and you can see exactly all the components I'm using. So anyways, this uses the, we'll open it up here, and you see we got my circuit board on here, and if I can, well, I can't read the chip number, but I think it's it's available on SparkFun. I'll again link that in the description. It's the MESQU7, something like that, I think. It'll be linked in the description. And it uses the ATmega 328 to drive the display and read the analog data coming out from the display chip. It's just got some slide pots here for adjusting the input sensitivity, and just a little TO92 voltage regulator in it. So really, a really simple project. So we'll plug it in and see the display. Again, it just uses one of these wall wart DC jacks. Fairly simple and easy to use. So we just plug it in, and it's upside down. I forgot. So here's how it works. There's each of these bars, and these each correspond to the different frequency bands of the chip. This lower band is about 60 hertz. This upper band is about 16 kilohertz. And there's various ones in between. This might be 8, and this might be 4, 2, 1, and maybe 500, I think, or maybe that could be wrong. Again, it also displays their levels. There's 64 pixels on the screen, so I'm basically, what I'm doing in the code is analog reading each of the 7 channels off the chip, mapping them to 64, and then telling the line to draw itself to that mapped value, and then displaying that value above. But I can turn that off in the menu. This thing has a menu system built into it. As you can see, this would be the input jack here. This is one of the buttons for the menu. The other button is this wire right here, actually. It's a AC hum touch sensor. It's a bit glitchy for this project, but I showed it in another video. But it sort of works. So if you can see, if I press this button here, it'll say, again, it glitched on that time. Sorry, this may be a bit glitchy. But if I press this button, pressed it for too long. Yeah, it says show level. Don't know why it's... And then it goes to bar max. So if I can get it to... It keeps going to hide show. There we go. Okay, so I can turn on and off the values if they're getting in the way, and then I can display the maximum value instead of just the bar, so just the maximum value will be displayed. So this is maybe not so good if you're listening to like music on this thing or something, because then these bars will be jumping all over the place and you can't see them. But if you just want to make a measurement or something, this maximum value can be handy rather than just the bar. And again, we can turn on and off the numbers. So if we can get this to go to the bar, there we go. So this is the standard state. Sorry I won't be able to play any real music for you. I'll have to go for copyright-free stuff, but that's the way YouTube works. So if we turn this off, we can get a closer look at how I actually built the thing. It's built in this wood case, just drilled some holes. Fairly simple, just hot glued everything in. And this is actually a real simple project. I took my time on making it. It took me a few hours, but basically, I just have each audio input channel going to, these pots are set up as a voltage divider, so the inputs from the channel go here, the outputs are sent over to the, are basically tied together, sent over to the chip, and these are connected to ground, the bottom of the pot. The chip is connected in the circuit shown in the respective tutorial for that chip that I used, so go look that up. It'll be linked in the description again, and on the project page. And that value is then fed into the Arduino, where it's read by the Arduino. Sorry, I can't actually show you this circuit board. It's sort of stuck in there pretty good. Where the values are analogically read by the Arduino, and then sent to the screen. And that's really it. There's a bit of AC hum touch sensor circuitry in there, and then down here there's the voltage regulator circuitry. But that's really it. Again, on this one, I use the same technique for programming the thing with an FTDI cable or an FTDI adapter that they sell at SparkFun, instead of just using a full-fledged Arduino board like that, because that's a waste of money. The chips are really cheap. So, I mean, that's the project. It's really an easy, simple project to do. No issues in building this project. It really should be fairly trivial to actually implement this. The only issues I had were with this AC hum touch sensor. So maybe you can just replace that with a, regular button. So I will now plug this in, and again, you can just see sort of how it works. These bars and these input levels aren't calibrated to anything. You could calibrate them if you want, but they aren't calibrated to anything. And this really here is not really a laboratory grade equipment. You can see if I touch the end, all the AC stuff is, all the harmonics are getting through. But then if I ground myself, it's lessened. If I don't ground myself, it grows, and so on. So it's not really a laboratory grade thing, although you could use it for maybe low frequency lab stuff. But really I built this so you can listen to music and, well, you don't really learn anything from it because you can already hear it probably better than you can see it. It's a neat display to look at and perhaps useful for low frequency lab stuff. So I will stop talking now and let the music do the rest. Although we'll have this hooked up to my computer now with the speakers. Sorry, I'm not taking the audio directly off of the computer. I'm having it playing through some speakers here that you may be able to hear. And here's the display right here, so I'm just going to play some copyright-free music and you can see the display change. Don't know if you can see that very well. But these are the lower frequencies over here, and these are the higher frequencies over here. I'm just changing the input level here to get the best sensitivity. This music right now is by Ian Fever, just to cite him, but it is copyright-free music. Okay, so I'll stop that and do a frequency sweep now. So you can really see how this thing works. So this one is from 20 Hertz to 20 kilohertz. See how well this does. You can see how hitting the buttons affects it. So just waiting for the speakers to kick in here. You may not be able to hear it. As you can see, there's a little space between each bar, like some room where the frequencies, where the bars don't completely overlap and attenuate the signal. But you can see the YouTube turns off the frequency before that last bar fully got a chance to go. So that's the Audio Spectrum Analyzer project for you. Real simple and real fun to use when listening to music, because you can see the bars jump around. This is like your low frequencies, your bass drum. This is your high frequencies. Up these last two bars are usually just harmonics. Most music doesn't actually go that high, but their harmonics can be that high. I know you can't really see the actual numbers here very well, but let me demonstrate for you the maximum feature that this thing has. Okay, so here maybe you can see all these little lines on the screen, so I'm going to do that frequency sweep again. As you can see, my headphones just kicked off there, or the audio system on my computer just kicked off there. But in any case, that's the audio spectrum analyzer. That's how it functions. That's its various modes. And real simple, just using this display from BG Micro, 10 bucks, an Arduino, and a chip from SparkFun. Really easy, simple circuit. I'll draw it up in CAD software, publish that on the project page for this thing as well. And real simple to build. The code will be there as well. But as you can see, it's a nice clean result with relatively little work for a pretty nice audio spectrum analyzer that obviously it's not like the huge ones that people build with like the monster wall LED displays, but you know, it serves a purpose and it works pretty well. So, thanks for watching.